Good day, welcome back. Today we do grade 8, grade 9, grade 10, also covered in grade 11 and 12, but for today's lesson specifically grade 8 and grade 9, we look at working with parallel lines. I need to understand if one line is parallel to another line, then the gradient will be exactly the same. Parallel lines never touch each other, that means the gradient will have to be the same. If they ask me now to find the equations of the line segments that are parallel to line segment AB and it passes through a point K, which is 2 and 1. If it is parallel to this line, which means if I take a and I drag it from there through K, the slope remains the same. The only thing I need to now calculate is what will be the equation of this line that is formed if it passes through a point K, which is 2 and 1. And step by step we will calculate this information. Already I know the slope of this line because in our previous exercise we said the change in y over the change in x. So the slope of this line was 3 over negative 4. So negative 3 over 4. So the slope of this line will also be negative 3 over 4. I can see now that this thing cuts between 2 and 3, but not accurately through 2 or accurately through 3. So I will have to calculate. So let's look at the process of calculating the equation of this line that passes through K, but is parallel to AB. We have now calculated the equation of AB already in our previous exercise. So the equation of AB was the gradient, which was 3 over negative 4. And my C value I could read from the graph is negative 3. So y is equal to negative 3 over 4x minus 3. This is my equation. And if I substitute negative 1, I will get the answer of 2 comma something. Negative 2 comma something. If I substitute negative 2, I will get an answer of negative 1 comma something. If I substitute negative 4, I will get 0. So, I want to know what is the equation of this line that is parallel to AB and passes through K. Firstly, I know that the gradient is the same. Slope is the same. So, lines that are parallel, the slope is the same. So I say gradient 1 of gradient is equal to line segment 2's gradient, which is equal to negative 3 over 4. So now I go to my equation, y is equal to mx plus c, and I substitute the gradient in there. My next step is to take my coordinates of k and substitute that in this equation. So 2 is my x value, I substitute it there. 1 is my y value, so I substitute it there. And now I solve for c. So this will give me negative 3 over 2. I need to add 3 over 2. And I've got to add 3 over 2. And I get an answer of 1 plus 1.5 is 2.5. So my equation is negative 3 over 4 because the gradient is the same. And it will pass through 2.5 on the y-axis. And if I look at the line, I can see, oh, it looks like it could be 2.5. So that is then a legitimate answer for me for the line parallel to AB. What I want you to do now is to calculate the line that is parallel to CD, EF, and GH in the same manner. So, the line that is parallel to this one and passes through point K, let's just quickly look at that one. Copy this line and we paste it and we say, where will this one pass through? Right? Then I will look at the one that is EF. So if EF passes through K, where will he cut? And then last but not least, GH. Copy and paste. If a line is parallel to this line and it cuts through K, where will it pass the x-axis if they are parallel? And these I will calculate in the same like manner that I calculated the equation of AB. Remember, the gradient of the other lines will be there, but point K and 2, according to this information that is given, will be the same. I want to thank you for watching this video. If you liked it, tell your friends. If you loved it, tell everyone. I will see you in the next one. Do not forget to like, subscribe, and turn on your notifications to be notified when a new video is uploaded. Please share if you found it useful.